Welcome. So this is chapter 2, section 1. This is 2.1. I think it's the first 3 pages of your packet that I gave you. So first page front and back, and then the next page. So our target for today is to write and graph inequalities and find the solution of an inequality when given a value of x. Okay, so if you're forgetting what inequalities look like, go ahead and look down at this table. These are inequality symbols. It's less than, greater than, less than or equal to, and then greater than or equal to. So for these last two symbols, something you can remember, if anything is less than or equal to, greater than or equal to, it has half of the equal sign included. So that bottom line, I always think of it as half of the equal sign. Okay, so an inequality is a mathematical sentence that compares expressions. So an inequality contains the symbols less than, greater than, less than or equal to, greater than or equal to. To write an inequality, look for the following phrases to determine what an inequality symbol to use. So this is a really great chart to reference because it tells you that this less than symbol, when you are rewriting like in example 1, statements as inequality expressions, you're going to look for words like less than or fewer than. And then for the next symbol, greater than or more than. And then for the next symbol, less than or equal to, but also at most or no more than. And then at least and no less than and greater than or equal to for the last symbol. Okay. So for example 1, we have a great example here already. A number w minus 3.5 is less than or equal to -2. So we broke that down into 3 different pieces. A number w minus 3.5. So we wrote down w minus 3.5. That's our first part. Then there's our phrase that you can see in our chart, less than or equal to. So a lot of people talk about the alligator mouth is going to be pointing towards what's bigger. So if the number minus 3.5 is less than or equal to -2, the mouth of the alligator is going to be pointing towards and chasing after the bigger number, the greater value. So our inequality is w minus 3.5 is less than or equal to -2. Okay. So our example below is a little more difficult. Has a couple more parts. -7/10 is at least twice a number k minus 4. All right, so what I always look for when I'm trying to determine where that equal or less than or equal to number is I look for is. So here we have is at least. Okay, so what's on the one side? On the left, we have -7/10, okay? Is at least twice a number k. So if twice a number k is at least the size of 7/10, then we are going to do a less than and equal to symbol. Okay, and now we're going to rewrite the second part. Twice a number k minus 4. Well, if we're taking twice a number k, that's 2 times k, and we're subtracting 4. Okay. So when you're thinking of at least, I like to imagine just a number line, which we'll learn to graph in a moment. So if I say something is at least 1, that means the smallest amount that it could possibly be is 1. That's our minimum. It's at least 1, so it's 1 and everything greater. Like if you were to say at most 1, then 1 would be the highest you could get, the most biggest number. At least 1, that means 1 is our very bottom minimum. So for Example 2. A solution of an inequality is a value that makes the inequality true. It can have more than one solution. The set of all solutions of an inequality is called a solution set. So when you get more than one solution, it is considered a solution set. So on our chart, we have our expression, which is x plus 5 is greater than or equal to negative 2. Okay, so that's the expression we're always going to check. They give us different values. So for negative 6, we're going to plug negative 6 in for x. So negative 6 plus 5, is that greater than or equal to negative 2? Negative 6 plus 5 is negative 1. Negative 1 is greater than or equal to negative 2. Now, if that throws you for a loop, you have to remember that if you're looking at a number line, negative 1 is closer to being an actual number. It's closer to 0, so it is bigger than negative 2. Okay, then we try negative 7. So negative 7 plus 5 equals negative 2. So is negative 2 greater than or equal to negative 2? Yes, we know negative 2 equals negative 2, so this inequality is true. Okay, now we're going to try negative 8. We're plugging that in to get negative 8 plus 5, which equals negative 3. Okay, is negative 3 greater than or equal to negative 2? It is not. So what happens here is negative 3 is farther down the negative side of the number line. So we know that that is a smaller value. And what we need is a greater or equal to value. So this is not a solution, and it will not be a part of the solution set. Okay, here's a little note. This diagonal line that they have here, it means that it is not greater than or equal to. Whenever you put a dash through symbols like that, it just makes it not that. So for example, if we wrote an equal sign and we put a dash through it, that means not equal. Example 2, tell whether negative 6 is a solution of the inequality. So all we're going to do here is you're going to plug in negative 6. So negative 6 plus 4 is that less than negative 1? Okay, I'll do this problem with you, and you guys can do number 4 together. But negative 6 plus 4 is negative 2. Is negative 2 less than negative 1? Yes. So negative 6 is a solution of an inequality. For 4, you're going to plug it in. You're going to tell me if 10 is less than or equal to 3 minus negative 6. Okay. Our next step is we're going to learn how to graph. To graph an inequality, or the graph of an inequality, shows the solution set of the inequality on a number line. So these are the important things to know. An open circle is used when the number is not a solution. A closed circle is used when a number is a solution. And then you'll have an arrow to the left or right to show that the graph continues in that direction. So I want to talk about this for a second. So say we have 0, and we have an expression that says x is greater than 0. Okay, so it has to be bigger than 0, and it cannot include 0, right? Because it has to be greater. So some people want to skip to the number 1 and circle that and go on. Well, we know that we have fractions that go right up close to 0, which could be 0.0000001. And that's real close, right? So what we have to do is put an open circle on 0. And then since it's greater, it's going to grow and grow bigger down the number line. So we have our open circle because it's not equal to 0, it's greater. And it keeps going up and up because it's growing up the number line. So we're going to try this example 3. We're going to graph the inequality b is greater than -8. So you have to make your number line. Okay, and I'm going to put 0 on here, and down here I'm going to put -8. If b is greater than -8, we have to recognize that this side, the right side of -8, is where all the greater numbers are. So we know that this is the side that we're going to fill in with our color. Okay, so now we have to look at -8. Does it get a full circle or an open circle? So a full circle tells us that it is included in the answer. It is a solution. Okay, an open circle is not a solution. Okay, so if b has to be greater than -8, it's not equal to -8. So we know it's not a solution and it's just an open circle. Okay, now you guys try number 9. R is less than 1/2. So you're going to have your number line. I would put 0, 1/2, -1/2 on this side. And I would think about, what are we going to have on that 1/2? Is 1/2 included in the solution, or is it an open circle? And then in what direction do we go on the number line? Okay, if r is less than, then we're going to go that same exact way this arrow is pointing. We're going to go this way, down through the negatives of the number line. But if it is like 7, how the end of the arrow is pointing this way, and b is greater than -8, that's why we went towards the right. So for number 9, you have to choose open or filled. And then which way are we going to fill in our number line? Example 4, write an inequality that represents the graph. So this is just the reverse of what we did above for example 3. All right, what I'm going to do is I'm going to find that number that is plotted. So -6, whether it's an open circle or a closed circle, that -6 is what we need to have. Okay, so -6. Now we're going to look at this circle. Is it closed or is it open? We know this is closed. This is filled in, so it is including 6. So we know that it is at least, or it is equal to -6. Okay, but now we have to look at the rest of our shading. Okay, it seems like it is going towards the positives of the number line. It is getting bigger and bigger. So it goes from -6 all the way up to the biggest numbers of the number line into the positive numbers, and it keeps growing. So that means that -6 is less than, we'll say x. Okay, because it's less than or equal to. -6 is our very bottom number, and then our numbers grow and grow and grow and grow. So we have -6 is less than or equal to x. I'm going to do another example for this. So if we had a number line, and there's our 0, and we had a point at, here's -2, here's 2. If we had an open circle at 2 and it went down the number line, well, we would know one of our pieces of our statement is 2. Okay, and then we have our variable x for the other side. Now we're going to